Okay, let's consider the first problem. Okay, the first problem is like this. Okay, so we have the coordinate already, right? We have the coordinate already. So then we determine for the shape function. The first problem would like us to determine the shape function ni, nj, and nm. Okay, that is n1, n2, and n3 for this case. Okay, 1, 2, 3 for this case is in sequence because the node we set up like this. Okay, should be in sequence, in counterclockwise sequence. Okay, so then before we do that, we determine the area. Okay, area. Okay, you may use the formula that I already supplied, or you may doing like this. Actually, if we know the coordinate, we can determine it by using this formula also. This may be easy to remember. That is, you rearrange the coordinate like this: x, I, y, I. This is in mathematics. Okay, that you may have learned it before. Y, j, and x, m, y, m. Okay, and this is come back to x, j, y, j again. Okay, so the area is become, okay, down is positive. Okay, up is negative. Okay, so then if we know the coordinate, okay, for this case, it's equal to what? It's equal to 1 over 2, right? The coordinate node I is 1, 2. Okay, node J is with 5, 3, and node M is 4, 6. Okay, and come back to node I again. Okay, and it's equal to what? When we multiply this, okay, we obtain 1 times 3 plus 5 times 6, okay, plus 4 times 2, okay, minus 5 times 2, okay, minus 4 times 3, minus 1 times 6, okay, and after that we have the area equal to 13 over 2, that is become 6.5, okay, 6.5. And for this problem, it's not defined the unit. Okay, so the areas become unit. Power 2, right? Okay, and then we would like to determine the shape function. This is we have to determine alpha, beta, and gamma first. Okay, so alpha I is equal to xj ym. Okay, minus yj xm. Okay, alpha j is equal to yi xm minus xi ym. Okay, and alpha m is equal to xi yj. Okay, minus yi xj. Okay, so for this case, it's equal to 5 times 6 minus 3 times 4. It's become 80. Okay, and this become 2 times 4. Okay, minus 1 times 6. It's become 2. Okay, it's become 1 times 3 minus 2 times 5. and this become -7. This is for alpha. We do the same thing for beta, beta I, beta J, and beta M. For beta, beta I is equal to yi minus ym. Okay, so it become 3 minus 6, it become -3. Okay, beta J is ym minus yi, it becomes 6 minus 2, it becomes 4. Okay, beta M is yi minus yj. Okay, is equal to 2 minus 3, it's become -1. All right. Okay, finally, we find gamma. Gamma I is equal to xm minus xj. Okay, it's become 4 minus 5 equal to -1. Okay, and gamma j is equal to xi minus xm. It's become 1 minus 4, that is become -3. Gamma m is equal to xj minus xi. This is 5 minus 1. This becomes 4. Okay, now we have alpha, beta, and gamma already, right? Then we determine for ni, nj, and n. Ni is equal to what? Ni is equal to 1 over 2a. Okay, alpha I plus beta I x, okay, plus gamma I y. Nj is equal to 1 over 2a. Okay, gamma j plus beta j x plus gamma j y. Okay, nm equal to 1 over 2a. Okay, alpha m plus beta mx plus gamma my. Okay, and so on. Okay, xy is equal to what? Xy is the node at point P. For this problem, it's given us that point P is equal to the coordinate of point P 3.3 and 4.2, right? Okay, so then when we substitute, this is equal to 3.3, it's 4.2. Okay, we obtain Ni, Nj, and Nm for point P inside of this element. That is, maybe you may work out by yourself. Okay, so what is the solution for this problem? Okay, you're right in this case. And then we moving to the second problem. For second problem, okay, we follow the step. Okay, we would like to determine the element stiffness. Okay, so for this case, this is a plane stress element. Plane stress element, okay, it's given by this. Okay, actually, it maybe come from the big picture, the big one. Okay, but we just consider just only this element that we already solved for the displacement already. Okay, the coordinate is given by this picture, and all this unit in millimeter. Okay, unit in the coordinate is unit in millimeter. Okay, and E given by is equal to 210 gigapascal. Poisson ratio is equal to 0.25. Thickness is 1 millimeter. In order to form the element stiffness, we have to be careful the unit also. Gigapascal actually is 210. Okay, times 10. Okay, power 9 Newton per square meter. Okay, it is square meter, but all dimension is in millimeter. So it is easy to convert the elastic modulus to be Newton per millimeter instead. This may be more convenient for that. Okay, because we have to be careful when we apply the we apply the formula and the value from the given value, that it should be in sequence of the same unit. Okay. So E is equal to 210 gigapascal times 10 power 9 Newton per square meter, right? And it's equivalent to 210 times 10 power 9. We convert square meter to be square millimeter divided by 10 power 6. So it's become 210 times 10 power 3 Newton per millimeter square. Okay, you're right. And okay, this picture is maybe not correct. Okay, it's just the thickness. It should be 1 millimeter. Okay, we will follow the value, this value instead. Okay, the thickness is 1 millimeter. Sorry for this mistake. I select from the textbook, and the textbook is just note that it's just 0.01 meter. So it is 1 centimeter, but from the problem it is 1 millimeter. Okay, so then we have to change thickness is equal to 1 millimeter for this. Okay, and then from this shape, it's very easy to find the area, right? Because the area, this length is equal to what? This length is equal to 60, right? And the height is equal to what? Is equal to 120 minus 30, right? Let's become 90. Okay, so then the area is very easy to find. It's equal to a half times 60, 90, right? For this case, because the shape is very easy to determine the area. Okay, it's not necessary to use coordinate to determine the area, but for coding something, we may have to apply that way, because for coding or the routine, we normally have the coordinate. Okay, so then we have the area of 30 times 90. Okay, that is equal to 27,000. Okay, millimeter square. Okay, and do the same thing for beta. Okay, beta I, beta J, and beta M. Okay, beta I, beta J, and beta M is equal to what? Is equal to yi minus ym. Okay, it's ym minus yi, and this is yi minus yj. Okay, is equal to 30 minus 120. This will become minus 90. Okay, 120 minus 30 become 90. Okay, you may form this equation by using the table or something. That is maybe help you to determine each term. Okay, and also for gamma I, gamma J, and gamma M. Okay, you may do it by yourself. For this case, gamma I is equal to minus 30, is equal to minus 30 and 60. Okay, you may solve it by yourself. I recommend you to give the detail by yourself when you submit the class activity to. Okay, and after that, we can form metric B. Metric B is become 1 over 2A, that is 2, and A is equal to 2,700. And we have each element like this, minus 90, 0, 90, 0, 0, 0. Okay, 0 minus 30, according to the formula that you may check by yourself. Minus 90 and minus 30, 90, 60, 0. Okay. And for this case, it is a plane stress problem. For plane stress, we have metric D like this. This is plane stress problem. And then we have E is equal to 10 power 3, right? Okay. Okay. Divided by 1 over 0.25 squared. Okay. And what's next? And this is 1, 0.25, 0. Okay. This become, okay, we have metric B already. Then you can solve for metric K. K is what? K is TA. T is constant, we already know. A, we already determine. Okay, and metric B transpose, and D, and B. Okay, for this problem, we just would like to determine K11, K12, K13, right? Okay, but what? How about K21 and K31? Okay, actually we can determine just only K11, K12, and K13. K21 and K31 not necessary to determine. Because it is a symmetric case, so then K21 is equal to K12, right? And K31 is equal to K13. Okay, so then actually we can determine just only 3 terms, these 3 value. Okay, so you may solve it by yourself by expand this equation, by write it in metric form and multiply it by yourself. You will obtain K1, K11, K12, and K13. For K21 and K31, you may recheck by multiply by yourself again in order to check that it is equivalent with K12 or not. But actually not necessary to do that if you have the limit of time. Are you all right? Okay, that's all for the guideline for the class activity today.